Yes, dear students, good morning to all. Yes, this is a continuation class of previous class. Last class we discussed about disjunctive normal forms and examples on that. Similarly, conjunctive normal forms and examples on that. And let me do today the same continuation topics on that DNF and CNF. The topic title is principal normal forms. Principal normal forms, that is PDNF. Again, it consists. It can be divided into two types: principal disjunctive normal forms PDNF and principal conjunctive normal forms PCNF. Okay, and these are the uh, almost similar to the DNF and CNF. I will explain the main difference between PDNF, principal disjunctive normal form, and only disjunctive normal forms. Disjunctive normal form means there we have taken the sum of elementary products. Okay, is it clear? There we have taken the sum of elementary products is called disjunctive normal form. Whereas in a principal disjunctive normal form, yes, my voice is audible. Okay, see here. So in a principal disjunctive normal form, it is same the sum of elementary products with all canonical forms, or the sum of elementary products of all normal forms. So if it is, let us suppose, two prepositions are there, P and Q, then we have to write first these two prepositions all min terms. I will explain what is the meaning of this word min term. Min term means if it is two prepositions are there, then we can get 2 to the power of 2 total min terms. That is, if it is two prepositions, then we'll get 2 to the power of 2, that is 4 prepositions. They are called min terms. So the combinations will be as I will explain with one example. Just I will share the notes here. Here, principal disjunctive normal forms. Coming to the definition of this, an equivalent formula consisting of disjunctives of min terms. Yes, this is important. Disjunctions of min terms only. It consists disjunctive of min terms only. Then it is known as principal disjunctive normal forms. Or simply in one word, we can say it is a sum of products of canonical forms. Sum of products of canonical form is principal disjunctive normal form. Okay, in this here, coming to the what is the meaning of min terms? Min term means a min term which consists the conjunctions in which each statement variable or its negation, but at a time not both. Okay, I will repeat once again. Say a min term which consists of conjunctions in which each statement variable or its negations, but at a time we cannot get the both. At a time we cannot get the negation and its original preposition appears, and it can be appears only once. If it is repeated terms are there, suppose P intersection Q repeated 2 times, instead of 2 we can take only once. Okay, and for examples here, if two variables are there, or that is two prepositions P and Q are there, then we can get 2 to the power of n min terms, or simply we can say these are also known as Boolean conjunctions. So if P and Q are two prepositions, or two statements, or two variables, whatever it may be, then their min terms will be P intersection Q, comma, negation P intersection Q, comma, P intersection negation Q, comma, negation P intersection negation Q. These are the combinations. And for this, coming to the how we are going to prepare the truth tables. From the truth table of the minterms P and Q is as follows. Here, P and Q. First, let me write the all combinations first. So if two prepositions are there, then we can get the combinations either T, both are T's, any one of the T's, or both are false. TT, TF, FT, and FF. For this, first let me write all these four minterms combinations. P intersection Q, negation P intersection Q, P intersection negation Q, negation P intersection negation Q. So like this we have to write, and P intersection means apply the conjunction table. If both are true, then the resultant vector is true. Remaining three cases it is false. Similarly, P intersection Q, negation P intersection Q, negation P intersection negation Q, tables will be like this. And coming to the next points, these are important. It is clear that no two minterms are equivalent. In this, these are the four minterms combinations. In this here, any two minterms combinations cannot be same. Simply, they are not equal. All are independent from each other. Each minterms has truth table value T for exactly one one combination of the truth values of the variable P and Q. So we can select the each minterm as the truth value true only for exactly one combination of the truth value of the variables P and Q. Next, the methods for obtaining the PCNF, the methods for PDNF, the methods for obtaining principal disjunctive normal form. The methods for obtaining the principal disjunctive normal form are two methods generally we can use. One is with truth tables, another one is without constructing the truth tables. With constructing the or with the help of truth tables, we can obtain the principal disjunctive normal form, and sometimes without constructing the truth tables, also we can obtain the PDNF with the help of equivalence relations formulas. Already I given these formulas in previous classes. Now come to the first. Let me do the methods based on truth table, obtaining principal disjunctive normal form with the help of truth tables. So first come to the first let me discuss the procedure. For every truth value T of given formula. So finally we can select the last column. It consists how many T, that is how many variables having the truth value T, that combinations indicate the principal disjunctive normal form. Let me discuss one example, then it will be clear. For every truth value T of a given formula, write and select the minterms which also has the value T only, T of the truth value of the statement variable. The disjunction of these minterms will be equal to the given formula. So see here. Now let me discuss one example. I want to find the principal disjunctive normal form of P intersection Q union negation P intersection R. P intersection Q union negation P intersection R. Union Q intersection R. See here. So I want to find the principal disjunctive normal form for this. What is our question? P intersection Q union negation P intersection R union Q intersection R. In this, before going to obtain the principal disjunctive normal form, first we have to convert it into disjunction normal form. Once it comes under the disjunctive normal form, then you can write into principal disjunctive normal forms. The main difference is obtain the minterms. First here, how many prepositions are there? Let me find out that. That is the initial step. So here P, Q and R, three prepositions are there. If only two prepositions are there, then how many minterms we got? Yes, here we have tables here. 2 to the power of 2, 4 combinations. If it is 3, then we can get 2 to the power of 3 minterms will be get. That is totally 8 combinations we can get. And first write down that all 8 combinations first, then afterwards write down the minterms, then afterwards write the truth tables, whatever the given question based on that. See here. First, what about combinations? Yes, 3 are twos, any two of the true false, that is TTT, TTF. These are the total 8 combinations according to the 3 prepositions: PQR, TTT, TTF, TFT, TFF, FTT, FTF, FFT, and all are false, false, false. Here, the midterms will be, just write on the TTT means P intersection Q intersection R, and wherever T is there, write preposition as it is. Wherever F is there, write the preposition with negation symbol. So second one is TTF means P intersection Q intersection. F means F having R having the F quantity. So negation R. Similarly, TFT. TFT means F intersection negation Q. Why I am writing here negation Q? Because Q having false statement. So negation Q intersection R. Next, P intersection negation Q intersection negation R. Negation P intersection Q intersection R. Negation P intersection Q intersection negation R. Negation P intersection negation Q intersection R. Negation P intersection negation Q intersection negation R. Okay, these are the combinations. Now coming to the whatever the question having that individual quantities, we have to prepare the table first. So first we can say it is a sorry for the disturbance due to signal problem. Okay, so totally we can get 2 to the power of 3, that is 8 midterms, and wherever P is there, right? T. Wherever negation P is there, right? Wherever false is there, right? Negation P. Wherever Q is there, right? T. Negation Q, right? False. Okay. Just I will share the notes. So this is min terms. So T T T, that is P intersection Q intersection R. If it is TTF, P intersection Q intersection negation R. Why I am writing negation R? Because R having the false condition. Wherever false is there, corresponding variable or corresponding proportion will goes to negation. Similarly, coming to the last one, F F F, all prepositions having the false means we can write negation P intersection, negation Q intersection, negation R. Now, after filling these three columns, that is these four columns, three prepositions and minterms, then based on these minterms, write as a question format. What about question? Question having the three sum of the products of three quantities, that is P intersection Q, negation P intersection R, Q intersection R. Let me write down that columns individually. First, P intersection Q. P intersection Q means write the conjunction formula. Conjunction. If P and Q are both truths, then only the statement is true. Remaining all cases, it is false. Based on that here, I written P and Q are TF. Q is T. Third one's here. Q is F and P is T. Result is false. Like that, I prepared P intersection Q. Similarly, negation P intersection R. Negation P intersection means this is P. First, write it into negation of column. Then afterwards, negation P intersection Q. So negation P intersection R. That column will be here. F, T, F. Similarly, last one, Q intersection R. For this also, Q and R, we have to prepare the conjunction table. Wherever both are T, the result is T. Otherwise, it is false. So after preparing these three, that is products, P intersection Q, I am assuming that is X. Negation P intersection R, I am assuming that is Y. Q intersection R, I am assuming that is Z. So I got three products and I want to club these three products with union. That is sum of these three products. That is the principal disjective normal form. See here, I assumed first one is X, second one Y, third one Z. So what we have to find? P intersection Q union negation P intersection R union Q intersection R. So X union Y union Z. So again apply the disjunction table as disjunction truth table. So if union means among these three, any one of the statement is true, the result is true. If all are false, in that situation only result is false. So here X union Y union Z, TFT, at least one of the variable unknown, at least one of the quantities for true, then result is true. And here in third one, three quantities having the false. This in this type of situations only the result will go to false. Fourth one also false, fifth, sixth, seventh, like that we have to prepare all that. And finally, I want to write principal disjective normal form. This column is only disjective normal form. It is not principal disjective normal form. So write this as a principal disjective normal form by selecting only T truth table and that last column where T having, that is true value is having. Select that one only. Remove that false statements. Wherever F is there, that remove that one. Do not write that one. We have to write only T combinations where the last column having the truth value T. But that only we have to select. So here among 8 we have first one T, second one T, and fifth one T, seventh one T. So T union, write all that. So what is its corresponding T means? See again min terms. I'm not going to write this all T. T that corresponding T min terms values are the answers. Okay, that corresponding T min terms values are the answers. So what is first one T min term? P intersection Q intersection R. Yes, I am writing that one here. Next, second one T. That min term is P intersection Q intersection negation R. Yes, I written here. And the next fifth rows here T. That is negation P intersection Q intersection R. Similarly, seventh one, last, this seventh one here. We having T here. What is its corresponding min term? Negation P intersection negation Q intersection R. So that is final combination. So it having totally 1, 2, 3, 4 combinations. See here. What is our question? The principal disjective normal form of P intersection Q union negation P intersection R union Q intersection R is, this is the answer. P intersection Q intersection R. P union P intersection Q intersection negation R union negation P intersection P intersection R union negation P intersection negation Q intersection R. So these are the required principal disjective normal form to the given statement or given formula. So just check out what is the difference between these disjective normal form, principal disjective normal form. Where in disjective normal form, just we written last statement as it is. But whereas in principal disjective normal form, each and every individual product, it consists all prepositions simultaneously. If any one of them missing, either P among PQ or P R is missing, write it into in terms of R. That's why I am writing the first min terms here. All min terms having the three preposition simultaneously. In first one, second one, up to eighth one. PQs PQR, PQR, negation PR, negation PR, negation Q. All are present. So here, individually, the final answer consists three prepositions parallelly. P intersection Q intersection R, like this. Okay, this is the required principal disjective normal form. Let me discuss one more. Yes, let us do without constructing truth table. This is with the help of constructing truth table. Yes, I got that. Second method. What about second method? Same, obtaining the principal disjective normal form without constructing the truth tables. So this is we have certain structure. Just I will explain the structures today. Next class we'll discuss the problem. First, we have to follow all these principles. So without constructing truth tables, we have to use the following steps. What about first step? First, we have to replace all biconditional and conditional. Means double implies into an equivalent to their formulas, either union or intersection or negation formulas. Okay. If it is P implies Q is there, what is P implies Q formula? Negation P union Q, like that. So first we have to remove all conditional formulas, biconditional formula. If it is biconditional is there, P double implies Q, then what is it is equivalent formula? P implies Q intersection, Q implies P. Like that, we have to convert all conditional, biconditional into conditional and biconditional into equivalence formulas. Okay, equivalence formulas into intersection, union, negation. Okay, and step 2, negations are applied to the variables De Morgan laws. If De Morgan laws are required, we have to apply the De Morgan laws. Then afterwards, apply the negations, apply the distribution laws. Okay, distribution laws. Apply the distribution laws. So the step 3 is apply the distributive, apply the negations are applied to the given variables. If it is De Morgan laws are needed, we have to apply the De Morgan laws. Next, afterwards, apply the distributive laws. Next, fourth step, any elementary product which is contradiction, that is F, we have to drop it. Means here in previous table also here, in truth table also here, I taken only T column values only. I removed all F. So I written only combinations of T. So that is the meaning of this. So if any elementary product which is a contradiction F, simply we can drop it. And minimum min terms are obtained in the disjunctions by introducing the missing factors. The next, identical min terms appearing in the disjunction are deleted. Like here, for example, P intersection negation Q union P intersection negation Q implies P intersection negation Q, means if any one of the quantity is repeated, write it into only once. Okay, and P union P is there, right? Only one single term, and use the following principles while simplifying the PDNF. That is, wherever P intersection T is there, write P, or if it is P is there, write it into P intersection T. Okay, P intersection T, and in the place of T, yes, third formula, introduce Q union negation Q or P union negation P. Okay, if two prepositions are there, P and Q, but in the question we have only P, first write that P into P intersection T. In the place of T, again introduce Q value, because each and every individual product consists of all prepositions. That's why I'm using these two formulas. These two are most important. So what is that? P intersection in the place of P, right? P intersection T. Again in the place of T, introduce Q union negation QR. If P is missing, P union negation P, we have to write it. Okay, these are the formulas which can be used in principal disjunctive normal form. Similarly, negation P union T is always equal to negation P. Like that, we have to write all this, and remaining 4, 5, 6 are it can be used in PCNF. We'll discuss that later. Okay, tomorrow. Next, see here. Yes, I will explain the one problems here. Yes, just listen. I'll do this problem in both situations, with table, with truth table, without truth tables. Here, obtain a obtain principal disjunctive normal form of negation P union Q. So here, obtain the principal disjunctive normal form. Obtain the principal disjunctive normal form of negation P union Q. So in this, first identify how many prepositions are there. Here we have two prepositions. Okay, so write this as a sum of the products of canonical forms. Okay, right. First, negation P and Q, it is equivalent to, as in this here, negation P I am writing as it is, intersection T I am writing first, negation P union Q I am writing negation P intersection T. So negation P intersection T, in the place of T I am writing Q union negation Q union Q. So actually here we have negation P union Q. So two prepositions, so P is separate, Q is separate. So in the place of P, write down negation P intersection T union Q. In the place of Q, P is missing. So Q intersection T. See here, I'm writing P intersection T first, negation P intersection first, negation Q intersection first. So then in the place of T, negation P is there, Q is missing. So just I am using these two formulas. Yes. P equal to P intersection T, Q equal to Q intersection T, like that. Then in the place of T, Q union negation Q, and in the place of T, P union negation P. So this is negation P intersection T means negation P intersection Q union negation Q union Q intersection T. In the place of T, I am using P union negation P. Next, apply the distributive properties. A intersection B union C, negation P intersection Q union negation P intersection negation Q union. Here also distributive property. Q intersection P union of negation P. That is A intersection B union C. So Q intersection P union Q intersection negation P. Next, negation P intersection Q union negation P intersection negation Q union P intersection Q union negation P intersection negation Q. Now, if any one of the terms are repeated, then write it into only once. So here P intersection Q, only one time it is, right? That is as it is. Negation P intersection Q also repeated one time only, it is not repeated. And negation P intersection negation Q repeated twice, write it into only once. So this is the principal disjunctive normal. So finally, I got each and every individual. We have two statements here: P and Q, P and Q, P and Q presents. So this is the principal disject to normal form of given negation P union Q. Okay. Similarly, if you want to do same this problem with constructing truth table, see here, the two statements are there. Two tables will be like this and min terms will be like this. Then what is our question? Only negation P union Q. So negation P union Q, truth value will be last column. That is TF So among this, I already told in previous example, select only T combinations. So in this, how many T combinations we have? 3. Write it into 3. That is T. What is T min term? P intersection Q. Third T. What is P min term? Negation P intersection Q. Last T. It min term negation P intersection negation Q. These are the answers here. We got with truth table or without truth table. We have same answers here. We got same answer. Okay. This is about principal disjective normal form. Okay. And next class we will discuss about the principal conjective normal form. Okay.